Hello and welcome to another math video. Here we're taking a look at our probability test. So we'll get started here. Number one, Yogurt Shop offers 5 different flavors of frozen yogurt, 9 different toppings. How many choices are possible for a single serving of frozen yogurt with 1 topping? So really we have 2 events here, the frozen yogurt and the topping. And there are 5 choices for yogurt, 9 for the topping. All we have to do is multiply those together. So under those conditions, there's 45 different choices you can have. Number 2 is very similar. Ruth Ann has 3 routes she can choose from to get from school to the library and 6 routes from the library to her home. How many routes are there from Ruth Ann's school to her home with a stop at the library? So really, again, 2 events here. She has her routes from school to the library and her routes from the library to home. All we do is multiply those together. There's 18 different ways she can go from school to home with a stop at the library. Number 3, how many different orders can you line up 8 cards on a table? Really, there's 8 events with 8 choices for the first one, 7 for the second, 6 for the third, and so on. So really that ends up being 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which ends up being 8 factorial. Hopefully you can find that on your calculator. 40,320 different lineups of 8 cards that you could do. For number 4, we have 9 students participating in the spelling bee. How many ways can they choose who goes first, second, third, and fourth? So the fact that it makes a difference who goes first, second, third, and fourth, this would be a permutation. There are 9 students altogether. We're looking at choosing the first 4. So a 9p4, that ends up being 3,024 ways. So 3024 for a 9p4. For number 5, looking at 7 singers, how can they be selected? Select 7 from 10 who came to an addition. Here we're not saying there's any difference between any of the 7, it's just you're either one of the 7 or you're not. So this would be a combination, so 10C7, and so we're looking at 120 different sets of 7 singers. Number 6, we've got 10 people on the ballot for regional judges. Voters can vote for any 4. Voters can choose to vote for 0, 1, 2, 3, or 4 judges. And how many different ways can a person vote? So really we got to break this down into pieces. We look at how many ways you could vote for 0 judges, which is going to be 1. And we add to that the number of ways you could vote for 1. Why did I put 6? There's 10 judges to choose from. So 10C0 is still 1. 10C1, of course, is 10. And we just continue 10C2, add a 10C3, and add a 10C4. So we calculate all those different amounts, and we get a total of 386 different ways that someone could choose to vote for up to 4 judges out of 10. For number 7, Lynn and Dawn tossed a coin 50 times, got heads 28 times. What is the experimental probability tossing heads using Lynn and Dawn's results? So their results, they had 28 favorable outcomes, meaning heads on the flip, out of 50. We should always reduce that down. That reduces down just by a factor of 2, so that's 14 out of 25. I suppose you could use the percentage as well. That would just be 56% for that one. Number 8, we've got a bag with marbles. So there's 8 red marbles, 6 white, 5 blue. Find the probability of red or blue. So red or blue. Okay, well, let's just see. Total marbles, 8 plus 6 plus 5. So that's 19 total marbles. So the probability will be out of 19. And if we look at red and blue, so that would be 8 plus 5, so that's 13. So 13 out of 19, which does not reduce. The fraction, I'm sure, is much nicer than the decimal. Number 9, we've got a spinner numbered 1 through 10 with each number equally likely to occur. What is the probability of obtaining a number less than 3 or greater than 7 in a single spin? So less than 3 would really just be 1 or 2. Greater than 7 would be 8, 9, or 10. So 1 through 10 is 10 possibilities. We got 5 of them covered, so 5 out of 10, which of course reduces down to 1/2. Number 10, suppose Q and R are independent events. Find the probability of Q and R. Again, they're independent, and we're finding and, so that means we just multiply those probabilities together. So we just literally do 0.53 times 0.87. And that's all we do with that one. Let's see, it ends up being 0.4611. And if you wanted to, you could write that as 46.11%. Either way is fine. But again, that's exact. I haven't rounded anything. So please stick with those exact answers. Number 11, we got 2 urns contain white balls and yellow balls. The first urn contains 3 white and 2 yellow balls. The second urn contains 10 white and 6 yellow. The ball is drawn at random from each urn. What is the probability that both balls are white? Well, let's see. So we got 5 total over here. We got 16 total there. So for the first urn, it's a 3 out of 5 chance. And we would multiply that, because this is an and for independent events, multiply that by 10 out of 16 here. Of course, that one would reduce. You just multiply those together. Once that's reduced, then that ends up being 3/8 for that one. So that's what we're looking at there. Number 12, suppose S and T are mutually exclusive events. Find the probability of S or T. So mutually exclusive means that the probability of S and T is 0. So to find the probability of S or T, we just add those together. So we just do 82% plus 13%. We got just about everything covered there. That turns out to be a total of 95%. So just about very good chance, I suppose, of that happening. Number 13, we got another jar. Let's see, so we got 3 blue cubes, 2 blue spheres, 7 green cubes, and 7 green spheres. If you select an object at random, what is the probability that the object is green or a cube? All right, so there's a couple ways to look at that. We could find the probability of green, and we could add to that the probability of cubes, and then we could subtract probability of a green cube in order to get the total. So if we look at it that way, green things, we got 14 green things, let's see, and then 5, so it's 19 total items. Cubes, we've got 10 cubes out of 19. Again, the 10 cubes are the 3 blue cubes and the 7 green cubes. And then we subtract the green cubes, because we counted those twice then, because we counted those when we were looking at green things, and we counted them when we were looking at cubes. So 7 out of 19 is what we subtract. Gives us a total of 17 out of 19 for that one. And again, I would just leave it as that fraction. And there's some other ways you could do that as well. You might just look at green or a cube. So you might say, okay, well, 3 blue cubes, not the blue spheres, 7 green cubes, 7 green spheres. So then just add those together because they fit those different things. And that works as long as we have kind of the full description there of what we have. Number 14 is actually very similar to 13, except now we're talking about socks. So let's see, Joey has 4 black dress socks, 3 black ankle socks, 6 brown dress socks, and 2 brown ankle socks. What's the probability Joey will blindly reach into a sock drawer and pull out a sock that is brown or a dress sock? Let's just figure out our denominator first here. So let's see, if we have 4 black dress socks, 3, so 4, 3, 6, so we're up to 13, 14, 15. So our denominator is going to be 15. And then if we just do this the other way, where we just kind of count the things that are brown or dress socks. So 4 dress socks plus, not the black ankle socks, plus the 6 brown dress socks, plus the 2 brown ankle socks. So that way, just kind of counting them each once, we get 12 out of 15. That's an equal sign there. That does reduce down by a factor of 3, so that would be 4/5, which is exactly 80%, but may as well just leave that as the fraction. All right, now 15, we've got a conditional probability question. We've got the table, did you watch more than 1 hour of TV last night? For third hour, 6th hour, just a yes or a no. And round to the nearest thousandth. So it does tell us to round there. Find the probability that more than 1 hour was watched, given that you're in the 6th period class. So really just looking at the bottom of this. So that's out of 18 people. 8 of the 18 did watch more than 1 hour of TV last night. 8 out of 18 is 0.4 repeating. So to the nearest thousandth, remember that's 3 decimal places, so 0.444. They asked for the nearest thousandth, so I just leave that as a decimal rather than switch to a probability or percentage. 16, very similar to 15, we've got another conditional probability. Find the probability that the student preferred morning classes given he or she is a junior. So only looking at the juniors, let's see, that's out of 37 people. It does say to round to the nearest thousandth again. So preferred morning classes, 20 out of 37. I kind of agree, just get it out of the way. You're done for the day, get the rest of your day to do stuff. May as well just get it done in the morning. So to the nearest thousandth, 0.541, because it says 0.5, so it becomes a 1. Number 17, same sort of deal. Table shows the results of a survey of college students. Find the probability the student's first class of the day is a humanities class, given that the student is male. So looking at only the male students, so that's out of 210, just from adding those together. Only 50 had the humanities class as their first one of the day. That turns out to be 0.238. When we round to the nearest thousandth, like it says to do. So 0.238. And then 18, here we get to different, it's still conditional probability, but a different style of question. I would begin by identifying the different pieces. So we have the probability that a bus is ready when needed is 84%. They also tell us that the probability the city bus is ready for service and has a working radio is ready and radio is 72%. They want us to find the probability that a bus chosen at random has a working radio given that it is ready for service. So, probability that it has a working radio given that it is ready. And so what we do there, and again, let me just write this down for you so you can see it. Conditional probabilities, probability of B given A equals the probability of A and B divided by the probability of A. So what we have is radio given that they're ready, so we're going to take the probability there of ready and a radio, put that on top, 72%. And then in the denominator, we've got the probability that it's ready, which is 84%. And so we divide 0.72 by 0.84. And let's see, what do we get there for that one? So to the nearest tenth of a percent, we get 85.7% for that one. Number 19 is similar. We've got probably the student likes art is 51%. So we'll just do probability of LART. That'll be 51%. Probably the student likes art, also likes science. So probability likes art and likes science. LSI, that'll be good. That one is only 15%. That's kind of tough. Find the probability that the student chosen at random likes science given that he or she likes art. So again, it's basically the same question as number 18. Find the probability that they like science given that they like art. And so what that's going to be is, again, the and percentage, 15% or 0.15, divided by the, oh, look at that, the just plain old art percentage, 51%. See how they like switch the order around there? So we just divide those out, 0.15 divided by 0.51, and to the nearest tenth of a percent again, approximately 29.4%. That brings us to number 20. Let's see, so traffic patterns show that if weather is rainy, there's a 50% chance of an automobile accident occurring during the morning commute. If the weather is clear, the chance of an accident is reduced to 25%. Suppose the weather forecast for tomorrow predicts a 65% chance of rain. So draw a tree diagram. No problem. Okay, so let's see. First thing is rain. So 65% chance for rain. And we have then, just by process of elimination, 35% chance of no rain. I'm going to switch colors here. So then this will branch off. If there is rain, there is a 50% chance of an accident and a 50% chance of no accident. And if we branch off here, if there is no rain, the chance of an accident plummets to 25% chance of an accident. And then that would mean 75% chance of no accident. And so, like, again, here, this is really probability of rain is 65%. And like this branch here, this would be probability of an accident given that there is rain is 50%. And so those are the different things that we're looking at. And we're going to try to find the probability that there will be an accident, or no, sorry, two probabilities. Probability it will rain tomorrow and there will be an accident. So here we've got the probability of it raining is 65%, and then there's a 50% chance of there being an accident. Well, if we're trying to find conditional probability, or an and probability, so finding this one here, probability it will rain tomorrow and there will be an accident. Again, that's our conditional probability formula, but now we want it solved for the probability of A and B together. Well, that just equals the probability of A multiplied by the probability of B given A. And so really we take those two things, the probability of A, whoops, wrong button, get my lightsaber back. Probability of A is 65% because it's rain is A. And then the probability of an accident given rain is 50%. So really just find 50% of 65%, which hopefully you could figure that out anyway. But that is going to end up being 32.5%. So I would just call it 32.5%. It doesn't really say about rounding anything, but 32.5%. And then again, it's just the 50% or 0.5 multiplied by the 65% or 0.65. And then find the probability there will be an accident tomorrow. Well, there's a 32.5% chance that there will be rain and an accident. So, but then we also can have no rain in an accident, and no rain in an accident would be 0.35 times 0.25. Let's see, that part turns out to be 8.75% chance. So we would add that to the 32.5% chance, and we get 41.25% that there will be an accident somehow, whether it's rain in an accident or no rain and an accident. All right, well, thank you very much for tuning in, and hopefully you found the video to be helpful.